This video is on calculations involving chemical formulas. So one of the first ones that we started with in this unit was the using molar mass to convert from grams to moles and moles to grams. And molar mass comes from the periodic table. So we're going to look here at question number 11 that I have up here at the top. Calculate the mass in grams of 0.454 moles of dinitrogen pentaoxide. All right, so dinitrogen pentaoxide, that is, since I see these prefixes, I know this is a molecule. So the formula for this is N2O5. And I have the moles and I want to go to grams. So I'm going to need to find the molar mass of this. So I have in this chemical formula, I have 2 nitrogens and I have 5 oxygens. So each nitrogen from the periodic table has a molar mass of 14.01 and oxygen has a mass of 16. So 14.01 and 16. So I'm going to multiply and then add those guys together. So 2 times 14.01 plus 5 times 16, and I get a molar mass of 108.02 grams per mole. So there are 8.02 grams are equal to 1 mole of that N2O5. So this is my conversion factor that I'm going to be using in dimensional analysis. So now I need to start with the number they give me in the problem, which is 0.454 moles of N2O5. And now I'm just going to convert that to grams. Moles are here, so moles have to go here so that they cancel out. And my conversion factor here says that in 1 mole, there are 108.02 grams of N2O5. So everything on top multiplied together, divided by everything on the bottom multiplied together. And I get 49.0 grams of N2O5 for the answer to that problem. Okay, well, what if it says molecules in the problem, like here in number 13? If it says molecules in the problem, that means we're not only going to have to use, that we're going to have to use Avogadro's number. Avogadro's number is given to you. It is on the front of your reference tables. Let me show you where those are. So this is Avogadro's number. It is particles per mole. We've dealt with 2 different particles. So we've dealt with atoms per mole and molecules per mole. Because we're dealing with molecules in this problem, that's the way we're going to use Avogadro's number here. So Avogadro's number 6.022 times 10 to the 23rd, and our particle is molecules per mole. So Avogadro's number converts between molecules and moles. And moles and molecules. So in question number 13, it says how many grams are in this many molecules of carbon tetrachloride. So carbon tetrachloride would be this, 4 chlorines and 1 carbon, since I see those prefixes there. And I'm going to have to go from molecules to grams. Well, I can get from molecules to moles using Avogadro's number. Then I'm going to have to use molar mass to go from moles to grams. So I'm going to go ahead and find the molar mass of carbon tetrachloride. Carbon on the periodic table is 12.01. And chlorine is 35.45. So 12.01 plus 4 times 35.45, and I get a molar mass of 153.81 grams per mole. So that's how many grams are in 1 mole of carbon tetrachloride. Okay, so now I have all my conversion factors. I'm ready to work this problem. 3.29 times 10 to the 26 molecules of carbon tetrachloride. Okay, so anytime you've established that you've got to use Avogadro's number, you want to go ahead and ask yourself, can I use it now? And if you have molecules or moles here, the answer is yes. So yes, we can use Avogadro's number. Molecules are here, so molecules have to go here. And so that means there are 6.022 times 10 to the 23rd molecules in 1 mole of carbon tetrachloride. So molecules cancel out. Now I have moles. So now I need to convert moles to grams, and I can do that using molar mass. Mole is here. Mole has to go here. And in 1 mole, there are 153.81 grams of carbon tetrachloride. Everything on top multiplied together divided by everything on the bottom multiplied together. 53.81 divided by 6.022. And my answer here is, calculator spit out 84,031 grams. I need 3 sig figs. So probably scientific notation is going to be my best bet for this. And so that's going to be 8.4 times 10. 1, 2, 3, 4 times 10 to the 4 grams of CCl4. Okay, and that's how you work with molar mass and Avogadro's number.